Okay, everybody, here's the third video in our series on reasoning and proofs, and this one is focusing on this part here, conditional statements. If you haven't seen the previous video on statements and compound statements and truth tables, you'll need to do that to understand what's going on in this video. There will be a follow-up video where we'll talk about how to use conditional statements in these applications down here. So a conditional statement looks like this. P arrow Q. Okay, if P then Q. That's what this means, if P then Q. Some people like to say it, P implies Q. Okay, so this is called the implication sign rather than just an arrow. But I like to say if P then Q, so that I get the ideas in my head a bit clearer. We call P, or the thing we start with, the hypothesis, and the thing we finish with, Q, is the conclusion. So here's an example. So if you say, if this month is April, then next month is May, then this month is April is your hypothesis, and next month is May is your conclusion. Now, sometimes, unfortunately, it might not always be as neat as that. So here are some conditional statements that don't look like this. So you have to think about it and work out what's your hypothesis and what's your conclusion. So I would rewrite these statements. Instead of saying the Cowboys win more when Michael Morgan is playing, I'll say if Morgan is playing, then the Cowboys win more. Instead of saying I will go to the party if Jody goes, say, if Jody is going, then I will go. And here, if Jody leaves, then I will leave too. So I've got my hypotheses on the left and my conclusions on the right. Start with the hypothesis, then which implies a conclusion. Okay, so now that we know what a conditional statement is, we can talk about the related statements. And these are the converse, inverse, and contrapositive. So if you have a statement, if this month is April, then next month is May, if you switch that around the other way, so if you reverse it, you're making a converse. Okay, so it's if next month is May, then this month is April. So you're switching your hypothesis and your conclusion. That's called the converse. If we do the negatives, if we do the negations of the statement, that's called the inverse. Okay? N for inverse, N for negative. Yeah? That's how you remember. So that means if this is not April, then next month is not May. Okay? Not P implies not Q. The contrapositive is where you turn the statement around and make them both negative as well. If next month is not May, then this month is not April. Okay? If not Q, then not P. So what you see here is actually all of these statements are true, because April is when it is and May is when it is. So May is the next month after April. That's a true fact. It's not always going to be the case. Sometimes if the statement's true, the converse won't be true. Let's have a look at some of these. So here we go. If I was born in Sydney, then I was born in Australia. Just use Oz to represent Australia. That's true. Sydney is part of Australia. If I was born in Australia, then I was born in Sydney. That is not true, because there are many other places I could be born. That's the converse. The inverse is if I was not born in Sydney, then I was not born in Australia. That's just absurd. That's false. Okay, because there are many other places I could be born. But if I was not born in Australia, then I was not born in Sydney, right? Sydney is a place in Australia. So if you're not in Australia, you're not in Sydney. Okay, so that's true. So the statement and the contrapositive seem to be linked. The converse and inverse seem to be linked. These two are true, these two are not true. Let's look at this. If x squared equals 16, then x equals 4. Actually, that's not true, I hope you know. It's 4 or negative 4. The converse would be if x equals 4, then x squared equals 16. That's true. 4 squared is 16. The inverse would say if x squared is not equal to 16, then x cannot be equal to 4. That's correct. The contrapositive, however, says if x doesn't equal 4, then x squared doesn't equal 16. That's not true, because negative 4 is not 4, but negative 4 squared is 16. So it seems like these two are false and these two are true. So there seems to be a bit of a relationship between the statement and the contrapositive and the converse and inverse, which we'll talk about more in a few minutes. Let's try and put these in truth tables. Now this is quite complicated, so I will try and be as clear as possible, but you may have to look at this a few times or investigate some of the resources as well as me. So if both statements, we have the statement here, the ground is wet and it rained, and the statement, it rained last night. Okay, so that's P and Q. So if both P and Q are true, then this statement here, if P then Q, is true. Okay, if the ground is wet, then it rained last night. If the ground is both wet and if both the ground is wet and it rained last night, then the statement is obviously true. But if the ground is wet and it didn't rain last night, then this statement here is false. Okay? Because maybe it's wet because of some other reason. Maybe the house is leaking, or they sprayed it with a sprinkler or something. Okay? So, because even though our premise, our hypothesis is true, our conclusion is false, so the whole sentence is false. However, if our hypothesis is false, if the ground is not wet, but it did actually rain last night, this statement is actually true. If the ground is wet, then it rained last night. Well, even though the ground's not wet, it did rain last night, so this statement, we have to accept it as true. And this last statement, the ground was not wet, it did not rain last night, but this statement remains true, because there's no evidence to say that it's not true. Okay, these last two are a bit hard to get your head around, because you have to see that, that there's not enough evidence to say they're not true, so we have to accept them to be true. Let's look at this second one. So let's switch it around. Take the converse. If it rained last night, then the ground is wet. Okay, so we're going to switch this around. So let's just think of it going this way. So if true, then true means true. If false, then true, we're going to say that's true, because if it rained last night is false, but the ground is wet, then this statement will still be true. But the other way around, if it did rain last night but the ground's not wet, then this statement will be false. And if they're both false, well then that means that there's not enough evidence to say that it's not true. Okay, so you'll see here in this example and this example, if you start with a true and then get a false, your hypothesis is true but your conclusion is false, the whole thing's false. If you start with a true hypothesis but have a false conclusion, the whole thing is false. Right, let's go to the next one, the inverse, yep, the negation of this is called the inverse. So if the ground is not wet, it did not rain last night. So what might help here if we put in some extra columns here? We'll put in the not columns. So if false, then false will give us true. If false, then true will give us true. Like we repeated here and here, if true, then false, you got a false. And then if true, then true is true. Okay, and we'll do the last one, the contrapositive, we'll do that quickly too. So not Q is not P. So if false, then false is true. If true, then false, that's false. If false, then true is true. And then if true, then true, that's true. See what I was doing there? I was doing the negation of this in my head because I took away that extra column. Okay, so that's them. That's the whole truth table. So you can see here that this column, the conditional statement, and this column, the contrapositive, they have the same truth table. And here the converse and the inverse have the same truth table. So we call those two logically equivalent. All right, that was a lot of information and a lot of things to think about. So why don't you go away now and do some practice on this? I'm sure your teacher has some stuff for you to do.